Mastering Concurrency in Java, Threads, Synchronization Explained. Welcome, fellow Java enthusiasts. Today, we're diving deep into one of the most intriguing aspects of Java programming, concurrency. Specifically, we'll explore threads and synchronization, essential concepts for writing robust and efficient multi-threaded Java applications. Let's start with the basics. What exactly are threads in Java? In Java, a thread is like a separate flow of execution within a program. It allows different parts of your program to execute concurrently, making your applications more responsive and efficient. Code example 1, creating and running a basic thread in Java. Java public class my thread extends thread, public void run, system. Out. Println my thread is running, public static void main string, args, my thread equals new my thread. Start, / start the thread. Here, we've created a simple thread by extending the thread class and overriding the run method. Then, we've instantiated and started the thread. Now, let's talk about synchronization. In multi-threaded environments, when multiple threads access shared resources concurrently, it can lead to unpredictable results. Synchronization helps us manage access to these shared resources to avoid data corruption and ensure consistency. Code example 2, synchronized method in Java. Java public class counter, private int count equals 0, public synchronized void increment, count ++, public synchronized int get count, return count. Here, we've synchronized the increment and get count methods of the counter class. This ensures that only one thread can execute these methods at a time, preventing race conditions. But what if we need more fine-grained control over synchronization? That's where synchronized blocks come in handy. Code example 3, synchronized block in Java. Java public class synchronized example, private object lock equals new object, private int shared data equals 0, public void update shared data, synchronized, lock, / critical section shared data ++. In this example, we're using a synchronized block to ensure that only one thread at a time can access the critical section of code, guarded by the lock object. By understanding and implementing thread synchronization effectively, you can prevent race conditions, maintain data integrity, and unlock the full potential of concurrent programming in Java. And there you have it, folks. We've covered the fundamentals of concurrency in Java, exploring threads and synchronization. I hope you found this video informative and helpful in your journey as a Java developer. If you enjoyed this video, don't forget to like, share, and subscribe for more Java tutorials. Until next time, happy coding.